Yes, yes. Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and how fast the BRC challenge can be run and anything else to do with language runtimes, compilers, typing systems, and whatever. Um, Everyone's being recorded. We'll be on YouTube within a couple hours. I guess that's my spiel. What here? And then Levo's trying hard to say his phone. Yeah, okay, fine. Yeah, okay. So I guess I have an opening thing topic go on here. I went and put an entry into the one BRC challenge. It's read a billion rows of a fairly trivial CSV file. It looked very similar to the Cliff challenge of some months ago, except the data set is simpler and not terribly much larger, somewhat larger, but not terribly larger. Um, and you do simpler math. Fine. So it's all about how fast can you nom through a billion rows, and the rows are average, I don't know, 10 or 15 bytes or something, or probably 15 bytes. So you're looking at a gigabyte or something, I guess 10 gigs. Um, and so I have an entry, and the entry semantics. Does anyone else want to say anything before I dive into this thing? No, I'm diving in pretty soon here if I find it. Da, 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 da. How about now? Yeah, okay, fine. So the entry has a bunch of issues that I hated, including it reformatted your file every time, so you couldn't edit and find things. So I have a non-formatted version or Cliff formatted version that I hacked on. And then there was a bunch of comments on Twitter like, I don't understand how this works. And so I was going to go through it for this crowd, but people can say something if they don't like it or what does this thing go away? Give me participants list. That won't do it. Look at that. Having popped the participants list out, I cannot unpop it, but I need it
So
so I can
what's
catch
the
up new people.
sorry, I missed what was the result? What'd you get vis-a-vis?
Oh, on my machine, it's 2.5 seconds. Um, let's see here. So that's 2.6. It's a little high for the average, but I'm running Zoom. So with no Zoom, it's 2.4 seconds. So there's 2.5.
Mhm.
Just as a curiosity for comparison, how long does it take you to just line count the file?
Oh, we should go do that. Here's the
Like if you just go
file.
to standard Unix WC and ask it to count the bytes in the file.
Oh, it takes quite a while. For one thing, I'm doing 20 cores, so I divide by 20. And it's much slower than what I'm doing here. So the line count folks could go rework their life if they wanted to. I did that. I did a word count on it just to confirm it had a billion rows and all that kind of stuff. And I don't remember now, but I remember it was much slower than what I'm doing. So more than 20
Cool.
seconds. So 2.5 times 20. So let's be 50 seconds. It's well more than a minute. I think it's close to 2 minutes. Okay. Uh, so here's the time down here with, Zoom running full tilt boogie. Also, every time I do it on Zoom runs, it probably pauses Zoom's ability to transcribe. So be prepared for glitches if I hit it very much. Let's see here. We'll do head dot dot one BRC. How about dot dot? Yeah, there we go. One BRC. So file looks like this, just row upon row. And so I was going to step through what I'm doing with the thing, and then people have a care. They say something. So there's an initial thing that just gets your arguments and names your file or defaults, and gets a work file directory, and then it runs through and prints out the answer. And work is where all the work happens. And the print out the answer was obnoxious because you have to get rid of encodings because it's the city names full of UTF-8 character things and the encodings all break, so fine. So here's work. Work says just go through and spawn threads and break them up. So I decide how many CPUs I'm going to use. And if your data set's tiny, I cut down my count of CPUs so I don't divide, a 100 byte data set by 20. That doesn't make any sense. And then I spawn threads, make a new work object that's going to be shared in a minute, and then I make a thread that takes it. And then I do joins, and I do a rolling set of joins, and I do a reduction after every join, and then that's your work. So each thread does a piece of work. Threads internally now, that's T-start here. They start by saying file channel open. This is essentially Java's mem map. I'm mem mapping a chunk. Everyone whips out to a different start point and gets their chunk. They were told where to start because that's happened up here when I spawned the thread. I said, hey, you go at your start point is your thread number times the length that each thread's going to do, which is just a 13 gig divided by 20. So however big that is, it's 900 megabytes or something. And then you're going to run to the end, and you're going to call, and you're going to loop by max map size, where max map is because Java's mmap will only let you mmap 2 gigs at a shot. So I can't just take 9 gigs on every core. I have to do 2 gig and 2 gig and 2 gig and some fractions, or however many in a fraction. So that's that loop. So the max length is what you end up with capped if you're at the very end guy and you're capped at the end. And then there's a little bit extra given because every core is going to run through his 2 meg chunk and then run a little bit extra to finish out his current line. And the next core, which is leaping into the middle of the file, starts in the middle of a line, maybe. He'll skip the first middle line part till he finds a new line, and then he'll carry on from there. So this is me, how do you parallelize a CSV file? Well, the answer is some guy who started a line goes ahead and finishes it out, even if it runs past the end. Some guy who starts in the middle of a line skips it, doesn't count it. So every line's counted once, but you break it up that way. Then I finally do the mmap, and I call do chunk. The s greater than 0 is just a flag saying I need to skip that first line, or if you're the very first chunk, the 0 with offset 0 chunk, you don't skip. Okay, has 0 utility. I pulled it out of Hacker's Delight. You can go read the description in Hacker's Delight. But it basically says if there's a 0 byte in a long. So I'm going to do everything in chunks of longs using software as a register. And along the way, I'll look for various bytes in a long. And I'll use this little utility. And you can go ask Hacker's Delight how it works. But kind of it subtracts 1 from every byte independently. And then it complements every byte independently. And if you subtract 1 and complement, you get a weird effect. If you go screw around, you see it happen. It tells you, something about who's got a 0 or who doesn't. And then the mask is to cover the 80 hex map is to cover the case where you have a high bit set already. And so subtract 1 doesn't do what you expect directly. So here's work. This is the first time actually work really happens. I go ahead and get the end of the chunk because I'll throw a Java exception if I try to run off the end, even if I'm going to ignore the bytes. There's the initial skip, which I don't care to make any fast, just skip a partial line because everybody's doing chunks of 2 gigs at a shot. So a line is 10, 15 bytes. So they skip some partial line in the slow way. I don't care. Then get this big old piece here, which I should subroutinize, and I haven't. Fine. Wow, I haven't run it into the chunk. The start of a chunk is always the start of a line is always the start of a city name. And I'm going to start this loop always pointing at the start of a city name. I'm going to get up to 8 bytes. Misaligned. I'm going to look to see if I have a semicolon because every city name is terminated by a semicolon. It's the only character you can't have in a city name. And that's done by taking your long, zoring it with has semi, which is just a whole long of semicolons, which is a hex 3b. Having zored you with a hex 3b, if you're now a 0, then you were a hex 3b, and that lets me find has 0 defined a semicolon and a line. So if this comes back with a 0, there were no semicolons, and I have to get the next word of the city. So I take this word and I add it to Nate.
You're testing the entire long for whether it has a semicolon in any character in one shot.
Yes, this is software as a register. Software as, no, wait. SIMD as a register, whatever, SWAR. I'm doing SIMD things. I'm asking all 8 bytes. Do any of you have a semicolon?
SIMD within a register.
SIMD within a register. Oh, within a register. There you go. Yes, thank you. So I asked, do the first 8 bytes have a semicolon? If you have a long city name, the answer is no. In fact, there's like an Andrea and an Alexander and an Alexandre with slightly different spelling on the last character. So the first 8 bytes do have no differences. And the last 2 bytes have a Unicode or not Unicode on a couple characters. So it happens in the actual data set. The test set has evil cases that have cities with giant names and cities that only differ in later or early, whatever. There's some test cases you have to pass as well. Fine.
Okay, and has zero is the thing that's collapsing each of the bytes into one.
Yeah. And again, like I said, go read Hacker's Delight for a great description of how it works. As far as I'm concerned, as far as you're concerned, it's a magic cookie sequence that takes 3 clocks, 1 clock after x86 wide issue, and tells you this cool fact. Once I have 8 bytes and I need to go on and get more, I start zoring them into Nate here, where Nate's going to turn into a unique city identifier that's crushed in a long. So I'm just collecting them there. I bump my 8. I have a weird corner case at the very edge of all 13 gigs. I have to handle a corner case. I don't want to touch it now. Otherwise, I'm going to read the next 8 bytes. If I read the next 8 bytes, I repeat the question. Hey, do I have a semicolon yet? If I do, I'm out because I loop to while and it has a 0. If not, I loop to while and I go accumulate them 8 at a time into Nate. So N8 keeps collecting 8 bytes that are just stored together of contiguous city names, one chunk at a time. Then
So
when I come out of
essentially,
there,
Nate is a hash of the string name.
it's turning into a hash of the string name, yes. I'm going to hash it a little bit more in a second here. Go get your trailing zeros. This is a JDK, but it'll turn into 1 or 2 clocks. There's a thing you do to get trailing zeros that's similar to Hacker's Delight. And I have a corner case you have to handle. If you don't, then I go ahead and collect where the semicolon lands, and I get the last characters.
Instruction now for trailing zeros on Intel?
I'm sorry?
I think there's an instruction now for trailing zeros on Intel. There wasn't until about 2010, if I remember.
I went and read up and made sure that this one had the instruction on Intel, and it does. And sometimes I have long city names, so I have to do more screwing around here. But otherwise, I end up with the city names 8 in, take the next 8, the next 8, the next 8, and then the fraction banged in. And my index has moved me past the last city, and then I skip the semicolon on the way out. And now I have the portion where I'm going to read the rest of the line, which is a fixed temperature. It has a leading optional negative. It has 1 or 2, but no more, and a dot, and always exactly 1 trailing. So it's not too hard to read. So I go ahead and get it. If it's a negative, do that. Otherwise, you get the next byte, subtract off 0 to turn it to a decimal. You have to scale if you get another digit or don't. You're going to do the last scaling for the fractional. So I end up with a 2 or 3 digit scaled decimal with the fraction just thrown away, hidden away. It's scaled up by 10, so I can get rid of the fraction. Negate if needed, skip. Go to insert you into my hash table. That's a work.insert. We'll look at that here. Here's work. This is the accumulation place. It's blown out big because I do a private hash table so that I get better performance out of the hash table. So there's a hash table size, there's a table itself. It doesn't resize. I will probably update this to resize the table because it doesn't cost me anything, I think, in performance to have a resizable table. Anyhow, you have an insert call. He takes this hash from the city where I've accumulated things. He does uhash final down here at the bottom of the screen. This gives me a unique 3-byte identifier for every city in the actual test case. With actual test cases, some weather data, and the cities have been around for a long time and had weather data for a long time. It's not terribly clever, so you could probably reverse some bogus city names to cause collisions. I rely on this being unique. It is on all the test cases that it's part of the challenge. I can talk how I got it if you want. It's not too hard to get these kind of hashes. Once I have the hash that is unique, I leave it at 4 bytes, but it was unique at 3, whatever. I then get a smaller hash into my table, which is too small to take a 32-bit or whatever, or a 24-bit hash. Then I pull out 2 words in a row, and the table's pairs of longs that are packed with the data. The packing is up here. The packing says I have this unique hash in 4 bytes. I have the count of times. I have a record for a city. There's about 250 million records, varies. So there's a Gaussian distribution on the cities. They have a Gaussian distribution on the temperatures with an average that is provided. So you cities in the, in Canada or Siberia all have, low temperatures, and cities near the border have high, but otherwise the temperatures are all bogus. Fine. Then there's a min max as a 3-digit decimal turned into binary. So, but that 3 digits goes up to 1,000. So, and I got limited of 65K, so it doesn't matter. Temperature sum is the sum of all temperatures, so I can get an average later. And that'll be the sum of 250 million, three decimal digits numbers. So back to my insert chi, I get a hash. I pull things out of the table. I do a key. The key breakout says, take this long and break it out into its parts. So I'm basically treating the long as a struct. I'm going to break its parts out and reassemble them later. I pull the key out. If my key misses on my unique hash, I have to reprobe. If it's actually a 0, then I have to go insert it. So the hash table initializes to 0 means it's empty. Otherwise, your unique hash turns out never has a 0 for anybody. And then I go ahead and compute preset my loaded words for what I want the table to look like, including the count key has just the unique hash into accounts, and min max of the temperatures have a minimum which is maxed, a maximum which is minned, and 0 sums. And I do a new city. We'll all look in a minute here, but it doesn't do anything clever. And then I reprobe and I reload all my variables that I've put in registers or local variables for the loop. And reprobe is down below, and it does something stupid. And eventually I find an empty spot in the table. And then I take my min and my max, and I do, pull the min out of the min max, do a math.min. Pull the max out, do a math.max. Pull the temp out, add it to the sum. Rebuild the min max as a long, and shove everything back in to the table where this 1 less than 32 is my first count for the first entry. So that was not first count. It's a count for whatever entry. So that added 1 to my count. Fine, you hash. Here's new city. I could be clever here. I'm not. I actually use a string. I shouldn't. Whatever. I just walk the min mapped backing byte buffer starting at the start point, which is where I got when I got here, until I find the semicolon, and that's the city. I didn't use swar here because new cities don't show up very often. There are only 413 new cities out of 13 gigabytes. So this code is not clever, but it's also not run very much. It's only run 13 times as you find 413 times as you find 413 new cities. Hash takes the unique hash that's 4 bytes now and turns it into an indexed hash into a table that's 16K. It's not terribly good. It's pretty fast, though. It's okay. I get like a 20% retry rate on the hash as it stands now. Reprobe just takes the hash and adds some bits and mods to the table size. The OR1 here is so that I'm always ORing by an odd number. And since it's a power of 2 table, I will guarantee iterate the entire table before I'll find everybody. It's fine. As long as I'm prime modulo power of 2, which the OR1 does. Here's another version of the same hash code that I use later in the reduction step. It's the same logic. The other unrolled reprobe loop is unrolled because I wanted to inline a bunch of parts. This one can be slower, and so it's done a little more nicer, where I call hash to get my small table hash, pull the key out. If the key is 0, I'm just going to return you the hash of where you're going to put something. And if otherwise you reprobe and go again, and it's a lot tighter because I'm not pulling all these variables out, because the expected cases and the other guys, I'm going to prefetch things once. I don't want them coming in and out of memory. I wasn't trusting the compiler to do all the right things there. That's it. You end up, after the end of a thread has run to its completion, he ends up with this work object, which is a hash table full of counts. I have 2 of them for 2 threads, or 1 thread going. Actually, it's 2 of them for 2 threads. 1 thread just reuses his work for his third chunk. He gets 2 gigs, and then 2 gigs, and then 2 gigs, and then 2 gigs, and then 1 and a fraction gig. Reduction says, hey, walk one of the guys and stuff things into the other guy. Pull from the W table, break the parts out using the breakouts. Look in the local guy, break his local things out, and then do all the math, sum the sums, mins the mins, and max the maxes. If it happened to be new, I have to do a little more work to go shove you in. New on one table, not on the other. Like if 1 2 gig chunk didn't find an instance of a city, then you'll hit new in the other chunk and it has to be shoved over. So a little bit of work there. And otherwise you reload back into the W's and go again. And that's mostly it. Everything else is a little bit of boilerplate. Here's the breakouts. Get the key by casting the long to an int because it's a low 32 bits. Oh, get the count, shift right by 32 and cast to an int because this is the high bits. Get the min, get the max, get the temp. All similar operations where you min, max, shift, and chop to int or subfractions. And rebuild just pulls the parts and masks and shifts and put them back together. There's a 2 string. It's very dumb. I do have to do an annoying sort. Fine. It only happens at the end after you've read all 13 gigs, so no one cares for performance anyhow. Here's the min, the max, doubles.
The sort is because you have to spit them out in city name order?
Yeah. Abha, Abjajan, Abakechi, Accra, Abadu, Adelaide, Aden, Abadabada. They're out in order. And that's part of the correctness checking. The guy has a golden rule, and if you're putting out hash order, everyone's answer will be scrambled. So they're not hashed order. They're fixed. Oh, shoot, shit. Arthur was here and I didn't notice because, damn it, things. Hey, Arthur. Sorry, you just missed the walkthrough for the 1BRC challenge here. That's it. That's the whole file. That's what it does. I claim it's not very clever. I also claim I got told I'm near the top, but they added a new test since I submitted that I'm failing. I'll have to go correct for the new test.
Yeah, and, more generic than I expected it to be.
Oh, yeah.
I mean, I was expecting you to be playing games that were specific to like, I happen to know this set of strings can be hashed perfectly with this magic number.
Well, that's what I did. It wasn't terribly magic.
No, it wasn't terribly magic.
If I look at the hash I get out of them, it's pretty good. I did do math not shown in this file where I took the golden set of guys and tried a bunch of hash functions and looked at collisions and looked at reprobe rates and things like that. This was like 2 days to write the code and 1.5 days to fight the test submission harness, which had a bunch of evil bugs, especially around Windows, but in general had a bunch of evil bugs that I think were only evil for me because I'm Windows and I'm doing other things. I don't know. It seemed odd to me that no one else didn't just have a huge fight going on like I did.
Nobody else uses Windows.
It could be, maybe that's the answer.
I'm a little surprised the submission isn't just like paste text here.
Yeah, exactly. That's what I thought. And then, if I put up a little Docker thingy that eats your submission and does some filtering for people being evil, or maybe you had to GitHub it so it cuts down the amount of evil people. And then it just runs the test and tells you failed and gives you the test case. And here's a pile of test cases and golden answers for them and leave it at that. But no, I can run the test cases internally, but only after I first edit the launcher script. So it says .mvn maven in .command instead of maven or .bat or whatever. I have to edit that. I had his default file constructor, because it's pseudo-randomly generated, puts character new lines in. So the Windows files are all bigger by an extra billion character returns. So I cleaned that up, and now I have some files. I have my test files that I made that got both, and I have to hack where it says effing Windows. Here I add or subtract that line according to whether there's new lines in the file or not. I'm not dynamic on the fly doing it. Yeah, it was a pile of grief. Like I said, it was like 2 days for me to code it, of which half a day was spent fooling around with hash functions. and sorting out that I could jam everything into a pair of longs, and that was the better answer than trying to get some sort of generic thing. Given the minimal count of cities in the speed run, it's probably tolerable to actually use a struct there, and you would get one more layer of indirection, but you wouldn't have the key count min max breakout. I'm taking longs, and I have some utilities to pack and unpack them. It's just like a value, Java value semantics, whatever the damn Valhalla, whatever the one is. I could have probably gotten away with a struct for every city that said, min max in the obvious way, and it wouldn't have mattered. I say that, and the reason I went here is because I wanted my table to fit reasonably in L1, and it didn't do that, but it fits well into L2, which means every core doesn't touch main memory whenever they're dealing with their own stuff, except to read. You look in here and you see there's basically no allocation except on the new city, which, like I said, happens 413 times per every 2 gigs.
And that array of longs,
Yeah,
there's no pointer in direction there. It's just an array of longs.
it's just an array of longs. That
Unlike
is
the
correct.
array of strings, which is an array of pointers to strings.
Right. The strings are only used actually in the final output. I don't need them I'm not using them to compare for equality, for instance. So they're only
Yeah, I keep
along for
thinking
the
of big data
printout.
people who talk about needing Valhalla because they want to have arrays of structs.
Yeah.
But you solved your arrays of structs problem by just saying my structs fit in a long. So
yeah,
array of long, done.
Right. I even looked hard at, can I get away with 12 bytes instead of 16? And then decided it would have been close, but not quite. It wouldn't be enough to be worth it. Right. It would shave me my 16K down to 12K. And I think Intel's 64K01, 32K01, or 64K01. Somebody know? This is like a Matt question. Anyhow, so there's some resizing. So there's some thought into the size. There's some thought into the breakout of per core. There's a thought that says never allocate. There's a thought that says use swar, which was kind of a pain in the neck when exploded out. It gets complicated for no good reason. Like there's nothing intelligent here. None of this is rocket science. This is all like fiddly bit, fiddly bit, fiddly bit, fiddly bit. Once you get it right, it's always right. If you change anything at all, it'll be wrong, and then it's fiddly bit, fiddly bit, fiddly bit. Suddenly you get it right, and then you don't have to touch it again. So it's kind of obnoxious. I don't know a better way to, I want to say, program it in a way that's easy to read, but knows that everything's going to get inlined. There is a question here, by the way, I didn't do, is I did get long on misaligned longs. I could have forced alignment and then done another layer of shifting. So I'm only loading from aligned longs, sequential aligned longs. That would be sort of another interesting question. Followed by a round of shift and ors to build up.
Right, but it's a memory mapped file. Like, don't you not get to pick the alignment in the source file?
No, this is misaligned because every line is a different length. The start of a city, I'm here at the start of a city. I guarantee this is the guarantee for this loop. City index, city X, that's the start of a city. So right. This get long is as aligned as the start of the city is. Well, every city is on a different power of 8 boundary. Not power of 8, whatever. A different mod 8 boundary. So this is always a misaligned. I could make only aligned loads followed by another shift mask, shift or to get.
Oh, aligned loads followed by you fixing it.
Yes. And now is an x86 misaligned long faster or slower than me doing a line and fixing it? As far as I know, it's supposed to be about as fast and not make any difference. So I skipped it. I would
hope the compiler is smart enough those are identical.
Oh, he would, yeah, the compiler just spits out a load 8, a move 8 on the x86, and it happens to be misaligned address. Like mmap has one indirection, I think, to get to the base, which I'm hoping the compiler inlines get long so that indirection gets hoisted out of the loop and I don't see it, followed by an additive index, which is an odd number sometimes. So the base of the 2 megs data is surely aligned on a gigabyte or at least a large TLB boundary line, but my index is always misaligned. Anyhow, my score apparently is faster than the leaderboard as of yesterday, and my code is visible, so I assume people will copy and make improvements. And I mentioned several I could do to make improvements on. I didn't talk about all the things you could do, but this is one of them. This is only for an edge case. It only happens on the last guy of everybody. Of all
Can
13
you
gigs, the last guy has to deal with this case. So I could move this case out and get this out, except do it once up here.
uh can you show the generated code for like all of this like in assembly?
No, because I don't have the flags for it. If somebody can whip the flags out, we can probably dump the generated code. To get it,
Right.
you have to go tell the JVM to go run in special mode to puke his assembly as he generates it, and then you can get it. I don't have the flags handy now.
Yeah. It
Um,
seemed
this
like
code is
I mean,
publicly available. The links are online. The links are in the doc. You can go find those flags and do it yourself.
yeah, I have no idea how to do that in Java. So
Well, it's mostly
that's
you have to go ask the interwebs, how do I dump assembly out of Java? And somebody says, oh, here's a horrific set of flags you use. And then you get a giant thing. Here's
yes.
Matt dumping something about JIT which looks vaguely correct. Java has an unsigned right shift operator. Yes, yes, it does.
I mean, I don't even know if I have a Java runtime. No, I don't even have Java C. Yeah,
Yeah,
I
well,
don't
you have
have
to
a Java.
install Java into that. Fine. You can imagine that this code spits out what you would think it would, though. This is like bread and butter for C2, for the compiler and the JVM. So this will do what you think it does, like you'd expect out of assembly.
Yeah. It's just like that cross-functional register allocation stuff. Like, you could, I think, fit this whole entire problem into the registers, and then,
Yeah.
like, I think this could be like much simpler than
Uh,
like what we're doing. But yeah,
well, the reason I have it complicated here is to get this effect, this swore, read, and build, because this is faster to 8 bytes at a shot, look for a semicolon rather than 1 byte at a shot, because it's
absolutely.
divide by
Yes.
8.
Yes. I mean, like you could do that also with SIMD, with unaligned SIMD. Just do
Yeah,
it
right.
directly.
And I didn't go to SIMD. And there are people who are trying the SIMD ops. So this whole thing could be repeated using SIMD ops and get a much wider at a shot.
Like
Yeah,
it doesn't even need to replicate the value. You can just say like, okay, you know what, XMM15 is this
right.
mask that I've allocated, and that's doesn't have to get reconstructed like or
Right.
stuff like that.
All these funny games like this thing is just, all these things just get land in a register. I mean, it's either 16 or 32. I think I'm still 16 registers. I don't have the 32 registers yet. But
Yeah,
this whole loop probably well fits without spilling. It should well fit in an Intel without spilling. All these little functions will just be inlined completely away. So the hot loop, this is where the big piece of the work is for finding the city and then carrying on throughout here. In fact, this whole loop probably goes without much spilling.
right.
The whole
Yeah.
9 yards should register allocate well.
I mean, that's like, without looking at the assembly, that's just like wishful thinking that the compiler did a good job on like the code, right? Versus like
Right. I
I'm
wrote
talking,
the Onat, I wrote
yeah,
the compiler.
yeah.
So I'm assuming it's going to do a good job on this.
I mean, that's like, yes, assumptions are dangerous,
Yeah,
right? Like
yeah,
we
yeah,
should
yeah,
always
yeah.
check the code
I
output
think I would
for
have
like,
been long ago hounded on if it wasn't doing good on this kind of crappy code. And as I said, I think I had, as of yesterday or day before, or 2 days ago, I have an award-winning number.
yeah,
Can it get better? Maybe. Can it get better by screwing around to save register allocator? Maybe. Maybe not. I don't know. I'd have to go look at like how these expansions come out.
exactly. Yeah, I mean, this is like, it doesn't need to. I don't think that we should have to guess whether the compiler did a good job or not. Like,
well,
that's
okay,
just easier.
here's a different way
Yeah.
to think about the problem.
Yeah.
In nearly every other case on the planet, you don't want to look at the assembly because you have way bigger problems to solve. And it's just good enough. And if it spills, and you walk away. Under these very tight, narrow, well-defined benchmarks, you can get down to the point where you really love the compiler to do something this or that specifically. It's important that it get this register allocated here and not there or whatever. That's very rare. So this is an odd case, and it's really a proof of concept. Can the compiler, as it stands, with the appropriate given code on the input, go fast? And the answer is yes, it can. Can it go faster? Maybe. It's already pretty fast. You, sir, are welcome to go try and take the challenge. The description, and it doesn't require any Java. There's a giant ass file you go generate. You can write whatever code you want, whatever language you want. See how fast you can go. I know Levo took my CSV challenge and went to town with SimDops in C code and got a double speed, but he was also using double wide or quad wide SimDops, so it was reasonable. This stuff is okay, and I don't know if actually SIMD would help because most lines are actually really short. 8 bytes covers the vast majority of cases for finding the length of a city.
So some guy wrote it in C and claims to have gotten under 1.6, no, under 0.16 seconds for the entire thing.
0.1. That seems unlikely.
Oh, it's probably based on the file being fully cached already.
No, -2. I rerun it over and over. And you could have a higher processor count. It's entirely parallelizable. So I have 20 cores. The benchmark numbers are running on an 8-core machine, or maybe it's 8 plus hyperthread. I think it's 4. I think it's 8. But you could grab one of the monster machines with 128 cores.
That's what I think you did. Yeah.
Okay, it should. Yeah, it should. Well, if I did that, I took my 20, go to 128. You multiply by what? 5, 6 by 6. Divide my number by 6. Yeah, okay, you're pretty close. I'd be 0.8 without any effort. So you divide 24 by 6. No, 0.4. Oh, yeah. Sure,
yeah,
it can happen.
He's 0.151 seconds.
Yeah.
0.15 seconds, but like, is the file huge? I mean, it doesn't
13 gigs.
want...
The file was 13 gigs.
I posted a link.
I'm curious.
It's just crazy because I would expect at least there to be a decent overhead, like just populating the page table. Because when you start a new process, you do memory mapping.
So it's very interesting that the slowest part of it is unmapping. So munmap takes 185 milliseconds.
Why would you need unmapping? Like, you just quit. Like,
he's on a thread ripper. 128 cores, sure enough. Yep.
Pretty cool, huh?
unmap. What the hell? And that's part of your timing.
Yeah, you have to read the whole thing to get the flavor of it.
Yeah, aggregating results. Like I didn't optimize my aggregating results, but I could. I know how to do that. That's what H2O does, and that's pretty trivial.
And what's funny,
we did 2 layers of parallel aggregation. H2O will do log tree, all layers of parallel aggregation. It's actually pretty straightforward.
What's kind of funny to think about, though, is that the original, proof of concept, so to speak, that the author put up as the original author, Gunnar, he put up it took 4 minutes to run, which is probably about, because he's, put him in the top 10% easily of programmers out there, right? So you have most of the business apps out there doing the same thing, probably taking an hour and a half to do it, right?
Yes.
And now we have examples of, a fraction of a second.
Yes.
It's just kind of puts things into perspective.
Yes. I always frustrated hell in me watching how junky people write junky code. Fine.
Hey, like, no need to get personal.
Yeah.
Sorry. You're saying 0.1 seconds. I don't see any of those numbers like in the link you posted.
It wasn't 0.1. That was the low digit. So he's saying 0.15 in the title. 0.15. Where did he go here?
You have to look through all the. You have to read through the whole thing. He's got a history in there and everything. So
Here's point 4.
it's not apples to apples because it's a different
Yes.
hardware he's running it on.
Oh yeah. Is he running it in Java?
No, no, it's C.
Oh, it's C. Yeah, that skips a bunch of steps too. Sure.
Yeah, and there are actually two submissions that are Grail native as well.
I know. I saw those. They weren't at that time. They weren't doing good. I haven't seen the latest ones.
Oh, they're number 1 and 2, I think.
Oh, they are now. They weren't. They weren't as of 3 or 4 days ago, which I quit looking because I had other things to go do with my life.
I didn't look until today, so I've been
Okay.
avoiding. To me, this is one of those things where I could pour 2,000 hours into. So it's
Yeah.
like,
Yeah. 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 Yeah.
don't go there, Cam.
Right. I'm like, it's fun and it's obvious, and so you could burn. So I burned some. Okay, the current winners are in the 2.5 second for using unsafe. Oh, I have to go look and see what she's done. She did one earlier. It was more like, oh, they changed machines though. Ah, okay. So he moved to a faster machine. So my old times were all in the best case effort was 6 seconds, 6 point change. And my machine was much faster, was getting a 2.5, so it wasn't apples to apples. Now they've changed herself to a 32 core. There you go, 128 gigs. So I have a much faster machine. Yeah, right. Okay. Now it maybe pays for me to do my better version of reduction, use the log tree reduction. And then I want to go see what she's doing with unsafe. Or I think that's a she. I don't know. Quian May. Yeah, interesting. Okay, sure.
What are the main bottlenecks there? Is it reading the data? Is it sorting? Is it
Oh, it's
like
not sorting. So you have to funnel 13 gigs through your memory bus. The obvious beginner mistakes are you did some allocation for everything you read in. That's just a fail. You can't do any allocation. Um, you have to do something fast with the hash table lookup. So you extract a city. I think several of the winning ops, I don't know what the current top winner is, but several of the winning ops are using SWOR to go extract the city names. Several people tried SIMD. The lines aren't very long, so SIMD marches too fast, too far forward, so it's harder to make it win, but I'm sure you could. Then you have to have a good hash. You have to accumulate min, max, sum count without blowing yourself up with anything else. So I did it by packing the data into a pair of longs. Um, on these super fast high core count machines, reduction at the end might be interesting. I have to do joins. I'm doing thread joins. How long does a join take? Okay, once I got a join, I have two large hash tables, well, 16K entries that I have to walk through in parallel to go merge them. And then I have 20 cores, so I have 20 of these merges. I could log pre the merges, that would help. There's probably other things I could do to make that merge go faster. I don't suspect my merge is the slow part. I suspect it's the fiddly bits. There's too many fiddly bit tests for edge cases in the hot inner loop for my code. And I would
did you
guess parsing them.
did you profile it or just based on intuition?
No, because I didn't have the better. I need a machine code profiler at this point, so I need to pull out like vtune.
Uh-huh.
Like I boiled my inner loop. You missed the conversation on that. I boiled my inner loop down to a big old pile of integer ops doing SWOR to go extract out the city, and some kind of decently tuned hash functions that are a little stupid, and then a hash
I
table
mean,
lookup and accumulate.
the thing that you're doing like mmap like get was it the
I'm doing
function that
mmap.get in from the Java side, which
yeah
that
that
should turn
should
into that should turn
yeah just
into a
one
move
instruction
8 on Intel
yeah
of a
yes
direct memory address. It's a misaligned move 8. And then I could redo the alignment manually. That was another discussion we had. I don't know if that would beat an Intel misaligned load. I thought these days the Intel misaligned load was pretty good. So would it help me to do manually misaligned loads?
I
Aligned
guess so.
loads at 8 and then
Yeah.
realign them manually. Maybe it'll help. Maybe it won't. I don't know. Yeah, what's
Like
my current
I
bottleneck?
think
What's other people's current bottlenecks? Don't know.
yeah I think register 8 like is fine. Like you could even do like two compares like instead of doing like a move Like you could just say like, okay, this is I'm just comparing this memory base register with this register directly instead of like.
Well, that'd be, yeah, whether we want to the JIT's going to spit out there. I'm assuming the JIT probably loads into register because most of the time I take the register and I do an and an or and a shift and a XOR depending on the flavor of the line. So there's a bunch of memory, there's a bunch of integer ops, so I suspect they're all loaded up. You have to do
Yeah.
that SWOR business for finding the semicolon, which means
Yes.
you load a
Yes.
word and you or it with this thing and you and it with that thing and you XOR it with your other thing, and then it's zero or not.
Yes, exactly.
Right. So I think that's going to be all loaded. That's going to be load straight into a register and go.
Yeah.
I
Also, like,
is there a
there is
profiler built into won't help me though. I don't have VTune installed. But I'm going to use the profiler from IntelliJ, but it'll be a safe point profiler. It won't help me.
I'm actually thinking about building profiler directly into my IDE.
Oh yeah.
Instead of like depending on an external tool, because like VTune is like, okay, it's really nice that you're getting all those like cache misses and like all those
Yes. Well, it's the
like
cache misses that'll kill you.
and,
That'll be questions about, what's my hash table too big or not? Because as soon as
yeah.
it's too big,
I
you
mean,
get more hash misses or get more cache.
you could maybe put it in a history buffer if you're like, it depends on the distribution of data, whether the data was sorted or like
Oh, it's
if
not
it's
sorted.
random.
It's random.
Oh yeah.
It's
And mhm.
a Gaussian distribution of 413 cities with a Gaussian distribution of the temperatures that follow.
413 cities, I mean, that's not too much. I mean,
Yeah.
do you even need like a hash table for that? You could just say like, okay, this is like 4 bytes of hash per city fits in what, 2 kilobytes? I mean, that's an L1. And then you could just
So
search that with like Cindy.
you'll lose big to the hash doing that.
Yeah.
No, the hash says pick a line, compare once, 80% of the time it's right, 20% it's wrong. Pick a different line, try again.
No, I mean, you could still have the hash, but say like, okay, I mean, you could have like a hash with like bounded arrays is what I mean.
Right,
Like
right.
say like, okay, you can
I
search
have
like
a hash with a bounded array. I'm hashing into a fixed size array.
it's I mean, hash with a bounded bucket size
There are no
of like
buckets. It's an open hash table. There are no buckets.
I see. Yeah.
I'm hashing in and I hit or I don't. And if I miss, I go 20% of the time I miss and I go one more. And then you asymptotically drop off at 20% a shot. It's not a terribly clever hash, but it don't have a whole lot of bits to work with, so it never gets very good no matter what you do.
Right. I mean, it's also something about optimization is like, this is so synthetic actually, right? Like, why would someone ever do this? Like try to
Right.
parse like
It's
text
synthetic.
all the time.
And yet when I ran a big data startup, we saw plenty of data sets that had kind of a similar feel. They typically had more columns than two or three. This has four columns. There's a city. No, it only has two columns. Most of the data sets we looked at would have between 10 and 100 columns. And you typically wanted to look at any given moment, you wanted to look at either 2 to 4, or you look at all 100. Kind of varied.
Yeah.
This one's a little synthetic. Having data sets of a billion entries was kind of common for a big data startup. So you got big data, so you had a billion entries. People would have
You
like
would
unique
if it was
IP
in text,
addresses.
you would process it into something that's like normalized. Or like if you're receiving text, if you're processing text, like
Yeah.
why? I mean, it's
The
just
people would store it that way. This was one of
yeah.
those ask not the reasons why. There's always a better answer. That's not important. People took the easy
No,
answer.
it's I don't
This
think
was
like,
cheap.
because
They wrote
storing
text.
is like, okay, storing like a value like in text that's continuously have to be parsed to integer and like back and forth, like why? It's just so
Okay. So just to be clear, this was the storage format. Once we loaded into the big data startup machinery, of course, we parsed the integers all once. And of course, it was stored as some binary format. Of course, it was much faster in memory to go do things. That was the whole selling point of the product was, fast math. But when you started, the first starting point was invariably a flavor of a CSV. I had to say 95% of our inputs were a flavor of CSV.
So sometimes the data source that you're like getting your data from just you don't have influence over what they're doing.
That's right.
And sometimes I don't know.
Back
By the way,
in
like
the 70s,
working with text, the first thing would be like, okay, let's migrate this from text because why are we parsing text back and forth all the time? Like this is
no.
like,
Onat, you're thinking, you're not thinking about this the right way. People start by gathering the data because it seems interesting and they have no use for it yet. Later on, they find a use, but it's a different crowd from those producing it. So I've been doing these fintech startup thing, and we got these data sets from 70s, 80s, 90s, 2000s. Invariably, they were an ASCII dump, but there would be a billion entries of a kilobyte per. A big bank would do a billion sales a day, or a billion trades a day at a kilobyte of a log file per entry. So you get a terabyte a day of a log file, and it was text. The only people who cared to see that text was the folks doing compliance because somebody was suing somebody for cheating in the stock market. Right? So most of the time, this was write-only text. It had to be held onto for 7 years by all sort of laws. And Iron Mountain makes a business holding on to your file for exactly 7 years. And the day after the 7 years are up, they burn it with great force. And that's people pay big money for this kind of shit. I'm involved looking at the billion rows of random
it's
junky text.
it's still convertible to text if it's in binary, right? If
You
text is required in the future versus like, okay, we're just going to maintain this text database.
No,
which is like,
they had this shit going for
like
back in the 70s. It was only text because that's the only thing you thought about. But in the years since, no one was touching that stuff. It was the fear side of the house versus the greed side of the house. The greed side of the house gets all the money. The fear side of the house does something as safe as possible, which is what they've been doing all along, which is write the text out and put it off into cold storage and hope that God never ever looks at it. It's just a different mindset is what I'm going at here. The people producing the output typically don't care to see it again because they have it in some internal format that's easy to munch. They want to get some record and somebody else will look at it later, maybe not. And then companies like Splunk come along and, hey, we'll look at your gigabytes of terabytes of log file because, it's a pain in the butt to actually look at this shit. It is. But that doesn't make anyone else write anything other than text to a log file. So
I mean,
you have to deal with text.
Like you have to deal with like UTF-8 and you have to deal with like parsing numbers and decimals in your like parsing routine for what? For storing like 4 bytes.
But it doesn't.
Like we're afraid of storing 4 bytes.
Okay, all right, sir. Leave it alone. This is how the world works. I'm unable to change the world. So I live with it as it stands.
And quite interestingly, we're using audio to convey these thoughts, which is not terribly efficient. So Onat, we could rethink how we communicate as people.
There you go.
No. Audio is actually incredibly efficient. You're absolutely wrong about that because it can
compared to reading
so much nuance.
No. If I was to transcribe this,
and like
all right, Onat, we're gonna move on. This topic needs to be. We've beaten this dead horse. Done.
Sure.
Somebody else has a question.
I have a question. So have you tried pinning your threads and then shuffling like on different iterations, choosing a different shuffle or a permutation of pins and just see how much of a variance you get? I was actually very curious, like let's say you have lots of like dims. I was wondering if
lots of what?
Like lots of RAM sticks, like I don't know. I guess maybe on a single socket.
You're asking about my hardware. If I were to shuffle my cores around, would it matter?
Yeah. Like for instance, let's say you're on a NUMA system, or you have two sockets, and each of them have like their own like RAM that is closer. The question is, how is this file like stored physically in RAM? where like yeah, and to which cores are which pages the closest. And I was wondering, like, do you get a big
It's
variance in
whatever Windows
measurements?
does.
You do get a big variance, and in fact, you'll probably have seen these pictures that it's like a big square
Yeah.
with 128 by 128 with little, and it's color coded, and you basically get four quadrants with two of them being dark red and the others being kind of
Whatever.
a
Yeah.
so the dark red ones are basically the cost to access the RAM on the other
Yeah,
socket.
other socket. Yeah, you have to jump to the other socket. Yeah. And I'm not doing any NUMA related things. And I'm on Windows, so I don't know if how to go pin cores. So you have to match the storage layout of your 13 gigs as the OS caches it for your mmap versus your CPUs. So there
Yeah,
would be a quite
yeah. No, basically, I was suggesting maybe you could just try out, like shuffle around some things, and then maybe this way you can figure out.
I don't
This could actually give you some, could imply or give you
okay.
some
I don't
hints or
have
evidence.
I don't have any
Uh,
knobs to do that.
uh, you can't pin like threads to a specific physical core
I
on
might
Windows.
be able to on Windows, but I don't have any knobs to match the relationship to where the 2 gig chunk that this guy is reading landed. So I don't.
Um,
Both items are random. I don't have any way to ask the question. I'd have to go hunt to see if I could pin. So the question comes: can I ask the question of what is the physical address, which I know I can't ask. What is the physical address? Then if I had a map of my hardware layout, I could say these physical addresses are on this socket versus that socket. Now, there's a way to get that information. I don't have it now.
There
And I could
is
say, oh,
some
I'm
re
launching a thread doing this versus that.
there is some reverse engineering work for the DRAM hash functions that map the virtual address to the physical address of the RAM. So I would look into that direction.
Wow, you got a link? I never heard such a thing.
It's usually used for the DRAM side channels. I think it even started with Rowhammer and the related work,
Oh, okay.
because for Rowhammer you wanted to figure out where
Right.
in the physical DRAM chip what the virtual address location would be. So you would need to crack or reverse engineer this hashing function. They're usually relatively simple, at least in the older generations
Right.
of
Wait,
CPUs.
But you have
you're
to do
talking
that
about.
during your 0.15 seconds of runtime as well.
Sorry, but you're talking about like where in the like in a single DRAM chip it's located, or like in a
What?
single DIMM, or because I was just thinking which of these like RAM slots a
Well, you're
certain set of
striped
data is.
across 4 RAM chips or something. Depends on how your memory's laid out. I I don't actually. I guess I don't know. There was a time when you put in either twos or fours and you were striped across, so they double the bandwidth. Now I don't know, and I don't know what's in my box right now. I actually paid for somebody to build it out. It was custom designed but built out by the hardware store.
Generally, the fastest is for each bus you want one DIMM, and then
Okay,
there's a particular socket you want to put it in, and you have to read the motherboard documentation to know which it is.
right.
But they slow the DIMMs down when you have two DIMMs on a single channel.
Oh, I
On a
see.
single, well, on a single bus.
Right,
There's multiple channels per bus, so I'm using the wrong words.
right. Fine. Okay. Yeah, fine. Back in ye good old days, but that's not the case anymore. All right. What else? That was a good hour, but I can talk more about it or not or whatever. Like well, I'll have to go see what happens with Qui's solution here. Or it should be the same one, just on faster hardware too. I don't know.
And for future reference, Quan is a male name.
Okay. Yeah, I chased the link. It's still kind of ambiguous. I kind of guessed. I don't have
Well,
no.
I
Yeah,
know it's a
fine.
male name, so
Okay.
I mean, I could complain about cross compilation if people want to hear my frustration from last week.
Let's see if Theodore's got something or Adrian. Then
Sure.
we can come around to cross compilation.
No, I was asking for Yorick to continue.
Oh, I see. Oh, there's another vote. Well, I'll go one more here and say, Thalia, you got any you were gone for a couple weeks. You got anything interesting to talk about?
Uh, Honestly, I've kind of been like stuck on compiler stuff, so I haven't touched it in a while.
Ah, okay. Well, there you go. All right, Yorick, you win.
Yeah, sure. So the backstory is I was working on cross compilation for my language, and that started out with this thought of, it's going to be tricky, because I know that from like other languages it's a bit tricky. But I was like, yeah, how hard can it be? And well, I have been humbled. Let's say it that way. So there's the thing there is I am making it a bit more difficult than usual, in the sense that my language essentially consists of two components. There's a runtime library written in Rust, and that takes care of like thread scheduling and provides a couple of like primitive functions and stuff like that. Basically things I cannot express in my own language, such as share memory. And then I have my compiler, which through LLVM produces, its generated code, and then I link the two together. So that runtime library, normally when you install the language, that gets compiled ahead of time, it dumps like a .a archive somewhere, and then when you compile the code, the compiler knows where it is and links it in. So nothing too exciting. But with cross compilation, that kind of unearths various issues where it's kind of clear that at least compiling static libraries is not something a lot of people in Rust seem to do. Dynamic libraries, different story. People have done that, but even there, it's a bit more. It seems to be done in cases where people have like an existing C project and they want to have some sort of Rust plugin, like where in Firefox, for example, it's mostly written in C++, but they have some components in Rust. So that's, I guess, where you want something like that. But the majority of people, they basically build a sort of Rust executable, and that's it. And if you build a Rust executable, cross-compilation is fairly doable. Like if I want to target muscle libc, for example, it's fairly straightforward. If I want to target, I think ARM64 on Linux, off the top of my head, I don't know if you need to install an additional toolchain, probably. It gets more difficult when you want to target like macOS or Windows, because that's where you need to start installing the necessary SDKs, and macOS's licensing basically forbids you from distributing those files sort of ahead of time. So as far as I understand, it's basically this thing where you have to agree to this end user license agreement before you can use it. And they say something like, oh, you cannot use this on non-Mac hardware, stuff like that. So there's a lot of tools there that will basically violate that. They will download an installer image through questionable means and then run it on the QEMU and like pull out the necessary files and stuff like that. And they basically all exist because I guess Apple is like, yeah, we're not going to pay our lawyers to go after this, but it's very much in this sort of gray zone. And so one of the problems I ran into is if I cross-compile from x86 to ARM64, that is fairly straightforward. I had to extend my compiler to detect like, hey, if you're using GCC, then you cannot just give a different flag. We say, hey, GCC -- target whatever, because the big brains of GNU decided that each GCC executable only targets one architecture. Whereas with Clang, it's a proper cross-compiler. So if Clang, you do, Clang -- target arg64, whatever. With GCC, you need to install this extra toolchain, and then it's called something like arg64 Linux GNU.
Telling you, you should JIT
GCC.
everything. All these problems go away.
And so I had to make some detection for like, oh, if we're compiling for different architectures, sort of try these list of compilers. But then I ran into this issue where if I target muscle and
what is muscle? I've heard that name a bunch recently.
Alternative libc implementation, and their whole shtick is that you can statically link it. And so once you have a muscle executable, you can pass it around Linux distributions, and you don't run into issues with like, oh, this version of glibc is not compatible.
Yeah, right. Okay.
The problem I ran into there is when I tried to do that, it would spit out some linker error like, oh, unwind whatever is undefined. And I spent like the last 2 weeks trying to figure out what the hell is going on here.
Unwind exception throw, right?
So what I've now sort of the final conclusion there is basically Rust makes use of GCC's specifically libgcc dash underscore EH as a library for exception handling. But then it has some weird thing. It doesn't do that on all platforms, but it does do it on GNU hosts. And I still haven't quite figured out why, but if you compile on a GNU host and you target muscle, it insists on injecting GCC underscore EH as a library. So it gets specified in some object file somewhere. It says, hey, I need this thing. But then on the GNU host, the implementation uses a function called underscore DL find object, and that doesn't exist in muscle. So the linker's like, yeah, I don't have the symbol. What do you want? And so I spent like 2 weeks trying to figure out why does it insist on doing that. I'd run into this in the past, but at the time it's like, okay, I'm gonna look at this some other time. And this isn't the new problem. People were reporting similar issues going back to like 2018, 19, because that's around that time when Rust started depending on this. So people like, hey, suddenly I need to link these extra things with my static library. What the hell? Similarly, it depends on libgcc underscore s. That's not even clearly documented in the sense that when you install Rust and you remove that dependency, various Rust executables will just crash because they're like, this library doesn't exist. But it's not clearly documented. You need to actually install it. Eventually, what I ended up doing is I realized that the muscle toolchain that Rust provides includes a copy of libunwind, specifically a static archive. And then through digging through the compiler code, I found out that they include that when they target muscle, which would then explain why if you cross-compile Rust to muscle, it doesn't run into these issues. Because they probably had similar issues like, let's include libunwind. But this isn't documented anywhere. You have to go through like piles and piles of compiler and linker code to find somewhere in the depths. It's like, oh, hey, if muscle, add this thing.
Sounds like me trying to make a React Native app work.
So eventually what I ended up doing is, now as part of my CI, for all the targets that I want to support, it basically compiles this runtime library ahead of time, uploads it to S3, and then my compiler has a command to sort of download these necessary files. So if you want to cross-compile to ARM, you do something like Inko, runtime, add, ARM, blah, 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 done. Then for muscle, what I now do is I basically steal the libunwind.a from the Rust toolchain and just stick it in my archive. Yeah. Because I also don't know if Rust has specific version requirements. Like if I compile a newer version of libunwind and provide it, will it still work? I have no clue. So like, I'm just going to steal whatever version they use, also saves me the time to compile it. Then it works. Except when you use muscle GCC, it doesn't produce stack traces because apparently the wrapper for GCC when you want to target muscle, it doesn't pass this option called --eh frame header or something like that. Clang does it, normal GCC does it. For whatever reason, this wrapper doesn't do it. Took me a while to figure out, and again, somewhere in the depths of the Rust source code, it says, hey, if you use this wrapper, it doesn't add it, so here we do that. So I'm like, okay, I guess I'll copy that. So I eventually got it to work. Targeting macOS is still difficult. So what I ended up doing there is I have it, like I support using Zig as a linker. Because the Zig people, what they did, they were like, this sucks. We're going to rewrite all this ourselves. So you can cross-compile to macOS using Zig, and you don't need any SDK stuff because they implement all the necessary sort of glue code themselves.
Yeah, the Zig people.
And they have like, they provide libcs for like 20 different glibc versions and stuff like that. So it makes cross compilation a hell of a lot easier. So my compiler now basically said, hey, if you have zig installed and you're targeting Mac, we're just going to use zig automatically, unless you told me, hey, use a different linker explicitly. So for a brief moment, there was this ironic situation where cross-compiling to macOS was easier than cross-compiling to Linux muscle, because I hadn't fixed the linker errors yet.
You well convinced me to not ever try to do this.
So, okay, in hindsight, I spent most of the time trying to figure out what this muscle issue was. And I was mostly trying to figure out, okay, I have these 10 issues where people are reporting similar issues with similarly vague non-solutions. Somebody like, I removed this random file, now it works. And you're like, no, that's coincidence. You did something else that you're not writing down here. I've been there. So it's a lot of time just figuring out what the hell's going on.
I'm gonna bring a cat over here. We're gonna do a Zoom dog cat meeting.
So the final thing I've yet to figure out there is I support FreeBSD. I want to support cross-compiling to FreeBSD. Zig doesn't support that, so I can't use that. And it seems that nobody has made a toolchain to cross-compile to FreeBSD. The best I've been able to find was some blog posts from 5-10 years ago, where they're like, just get a FreeBSD installation and copy user lib over, and then remove everything you don't need and hope for the best, basically.
Could I ask you a question?
Where I have to... Sorry, go ahead.
Have you actually had people using FreeBSD file issues with you?
I think one person filed an issue, and I know somebody ported it to FreeBSD and is maintaining it. Now,
I see. Okay.
This is where I'm a bit on the fence, because I don't know how often people cross-compile from Linux to FreeBSD. I'm guessing not so much, because otherwise there will be more stuff about this. But that's where I'm a bit on the fence, in the sense that cross-compiling my runtime to FreeBSD is trivial. There's basically no cost in doing that. But it is a bit of a weird thing to say, like, hey, we technically support it. You just need to do all of these steps manually. Like, I would rather just say, sorry, we just don't support it. But that's where I have to, probably for now, I will just leave it and say that, like, we support it, but it's going to be difficult. But yeah, I now basically, my simple linker code is now, for the most part, detection stuff. Like, oh, if we are on a GNU host and you are targeting this, we'll try to use this command, like cc. Unless cc is gcc, then we have to do this other thing and pass this flag. And yeah,
that sounds like a mess to maintain.
Yes, and so I think in theory you can make it easier by not using clang, gcc, or whatever as sort of a wrapper, but go straight to ld.lod, mold, whatever.
Right.
Because one of the issues, these different compilers, they support like different flags.
Yeah, right.
Some will just silently ignore them if they're not supported. The thing there is then you have to figure, okay, for each platform that we support, where do they put CRT 1.0 and CRT, SRT, all those files? I'm like, I don't want to figure that out for now.
Right.
It's...
Yeah, somewhere in the guts of Hotspot, there's an OS and an OS CPU specific section where a lot of these things get squirreled away. We don't do linking the way you're doing it, though, so you don't have to do that piece of it.
I think my conclusion looking at it, it's I understand why these platform differences exist. I understand why certain Linux distributions will put like muscle installation files, so /user/muscle, and while others will do it in /user/libmuscle. But it's also like, come on, people, fucking standardize that shit for once. And also, all these Unix distributions use ELF. Why can't I just compile an ELF on Linux and have it fucking run on FreeBSD? As long as the shared library paths are correct. Yeah, that's Cosmopolitan libc, which kind of works around that.
It's so funny to me that this is the current state of affairs. This is like Linux is going to save the world from all the custom OSs on the planet, and it defeated all of them except Windows and Mac, which is still Linux vaguely.
I mean, it's very much XKCD was a 9.15 standards.
Yeah, right.
Somebody's like,
exactly.
I'm gonna fix this, and now there's 15 standards.
Yes, that's the one.
But it's these little things like on Arch Linux, if I install the ARM64 GNU toolchain, it puts its stuff in /user/rx64 Linux GNU or something like that. So like, okay, that's easy enough. Tested Ubuntu, some others, they did the same thing. Fedora, same thing. Except Fedora only includes the files that are needed to cross-compile the kernel. You cannot use that package to cross-compile user space applications. They just don't support it. And you can't really detect that from the directory contents unless you're like, oh, if this random file doesn't exist, we're going to assume. And so, okay, so you can't just blindly say if /user/whatever exists, use it, because then on Fedora, people get some cryptic error. And then Fedora puts muscle in /user/muscle, but then Arch Linux puts it in /user/libmuscle. I'm like, okay, fucking why?
Right. 1 billion per OS variant, whatever configuration options. Yes.
So in that sense, I really appreciate what SIG is doing, where they're basically like, we're just gonna bundle all these things ourselves, so we at least know they're in a stable location. And I really wanted to do that, but like, I do not have the mental energy for that. And also that will take me 6 months. Like SIG has like, I don't know how many people working on it.
Oh, do they now?
And they're still probably a few years off from fully properly supporting everything.
Oh, geez.
Okay. That's a lot of work.
Oh, yeah. Oh, geez.
Yeah, so that's
fine.
The end conclusion there is I have it working now, and I'm probably going to merge it and then overhaul all the documentation and probably put a warning up saying, cross compilation is difficult. Temper your expectations.
Okay. I will keep that in mind if I ever get there in AA. Wow. Fine. All right. What else?
So I could give an update about my language. Like
you have to
it's
keep
really,
you have to keep it short, but yeah, go for it.
Yeah, then I'll I can't keep it short. Like
once you get started, you get on a roll, and it's hard to limit here.
Yeah, I mean, there's so much stuff to talk about. Okay, let's see. Hold on. I'm gonna.
This was this fourth based looking all assembly, all fourth thing with a IDE and a GUI and everything.
Yes. Well, I can't share the screen, unfortunately.
I can fix that, but I am going to cut you in, I say 10 minutes. See if you can keep it under 10 minutes. And try screen sharing now.
Okay, sure. Okay, let's share the entire screen. Can you see that? Yes?
Yes.
Does that work?
Yes.
Great. So I'm actually going to try to go here. And okay, so I was actually compiling some shaders now, and I can see like the assembly output for the shaders also. Shaders are here, and I press. Oh, why did it? Okay, something's wrong. What?
He says, I can make these shaders do. Oops. Oh, never mind.
Yeah. So, there we go. So, yeah, I mean, I'm saying like I was mentioning that we should check what the compiler is doing, because for GPU stuff, the compiler is doing some very crazy stuff when you think about it. Like,
well, I'm definitely not doing any GPU stuff for that 1 billion row challenge. That's not a.
Yeah.
Not
I mean,
done GPUs.
It's not too bad, but it's doing some like crazy math with like
Adrian,
doing
that's the reason I bring him up.
loads. Like I don't even know what's going on here. It's just like offsetting the 248, and then like I'm trying to figure out like what the compiler actually intended to do here, because this is not even necessary, right? But the compiler thinks it is somehow. But yeah, yeah, I can write like I can generate Spurvy from this language in like this fast, so 0.77 milliseconds. That's not like so. It's just milliseconds, and like compile that in 1 second. I mean, if I change that, that's probably going to take more than 1 second. It's gonna take like 38 milliseconds, because the driver has to do the, has to recache it and so on. But it's a lot faster than doing like GL slang, because like GL slang would mean like, okay, you change some textual shader and then you pass it to GL slang compiler, which has to parse it and then like, generate something. Well, you can call it in memory as well, but it's like orders of magnitude slower than like generating the script yourself. Like, I think it was like 500 milliseconds or
You're
something.
not doing everything yourself all the time, or you never get anything done.
Yeah, well, I think in like I'm building towards like a fast system where I can like imagine very it's like where I can imagine and iterate very fast, right? Like that's the whole purpose of the system, is like I can say like, okay, what's going on here in this place in code? Like, okay, I got 13, for example, the 256 times. Like I got instant printf that's like impossible with any other language, because like their IDE, no language actually supports this, because yeah.
But I don't know what you did. So that's part of the description problem we have here is you're assuming we know too much of
So
what's in your head that's not in ours.
yes, so what I'm looking at is like printf like future built right into the language, and it's not hard coded. You can change what printf means depending on context. Like, and in this case, I'm just printing the value for R14, for example. In this case, where I'm iterating is like if I said like just gonna have 12 iterations, then it would have like I could visualize R14 as like this. Um, like it's instant visualization anywhere you want. Like you can say like, okay, I don't want to code, like I just want to skip over this stuff, and you can. It doesn't have to be like a whole thing. I'm like, yes, these values are in milliseconds, not seconds. So this is like 0.78. Like the iteration time is like unbeatable, because like
What are you iterating between hacking something and some splatter bits on the screen, but I still don't know what it is you're trying to iterate around.
oh yeah, well, this is C code. Well, C code as in like I'm calling Vulkan here into the Vulkan library, and like say 18 dev is like 18 is Vulkan create descriptor set layout, and that's a device function, because it's the
Okay.
%%.
You're calling into the graphics card drivers directly somehow.
Well,
Like I'm not
the
terribly
Vulkan
familiar with
drivers.
Vulkan. I've heard the name, but I'm not terribly familiar with it.
Yeah. The Vulkan is actually like a wrapper on top of the actual drivers, right? So
Yeah.
like
Okay.
the Vulkan is like a abstraction. Unfortunately, like I would love to go direct to the hardware, but yeah, Windows does not allow you to do that, so I had to use Vulkan. But like 21 there was create descriptor pool, etc., and like the syntax for this
Why aren't
is
you
like
using the okay, fine. But why aren't you using the longer name instead of 21 dev? Why aren't you using the Vulkan, create descriptor?
oh well, I would like it's compression, right? If I had like create descriptor pool, like I could like write
You're memorizing 21 maps to Vulkan create
yes.
descriptor.
Yes,
Yeah.
because like I know when I'm using 21, like I mean when I'm using dev, it means I call a function with passing device as the first argument.
Yeah.
So I don't have to keep passing that first device argument like all the time. If you look at like the create descriptor pool, like Okay, create descriptor pool. Like, what's yes, okay, yeah. I mean, you just have you have these parameters called device, create
Yeah,
info
right. So
algorithm, like
you've wrapped some Vulkan descriptors with your own versions that have pre-cooked certain arguments like the device.
yes. I mean, it's just a single
Yeah.
word that's like,
Okay.
how many like 1, 2, 3 instructions, just a word that's 3 instructions. And like same for instance, like, I got a bunch of those as well. And like I
Yeah.
can jump
So
between
and
all.
you're probably less aware, but it does make the code very you specific and no one else can read it because no
Yeah,
one
well,
else has these things memorized in their heads.
yeah, I would have to comment this out and then people can read it. Actually, they can listen to it. Like the idea is that I'm gonna record because like this is actually here, I got this separate symbol table, well, cells I call them. Each of them like 8 bytes long, and like, like I could just describe what this is doing, but I don't have to because I know. Like I can just go and say like, okay,
Right.
this
Yes,
is
but it makes it
DK, and then I can
it was
jump to, even if I forget, I can just jump to the definitions and then like
well,
I
you can in every other
remember.
language too, but it's even hard to read what definition is because people here aren't familiar with forth. I'm recognizing some of the things, but
Yeah, it's very different actually than like regular Fort, but
there you
I mean,
go.
it has the ideas of like I was designing this language around the ideals of Fort is the best description. Like, what should be an ideal Fort? Like, because like Fort is as traditionally viewed a very still like a runtime language, but I don't like runtime languages because they're like opinionated about what the runtime should be, right? Um, Versus there is no opinionation here. I can generate from the same
Oh, I think there's
language
a
of
very large amount of opinionation here, and it's just matches you better.
sure,
All right, we're gonna
sure. I
wind it
mean,
down here.
not
So
opinionation about runtime, but yeah, I mean, you know.
all right. I'm gonna
So
I'm gonna wind it off here. You got anything else you want to share in the next minute, and then I'm gonna kill it.
sure. I mean,
That makes sense
I
to
don't know.
talk about in 1 minute. I don't know. There's something here. You've got something going on, but it seems still a long ways separated from a usable reality for
I
anybody
mean, I'm
else. For you,
using it right
yes. For anyone
here.
else.
I can look at the like, like what's the result of this function is 0. Okay, that's a success. I'm using it. It's like
Yeah, I can't even tell you that you had a function other than I know it's fourth. Ah, it's
yeah.
fine. And you're dumping things out into windows that are not labeled or marked on the screen. So in your head it's a window, but I just see a screen with stuff just appears. All right, I'm going to be
Well, yeah,
done.
it's work in progress.
We're gonna claim done for the moment here. Um,
I mean, what I mean is like, I think the purpose of a language should be generating the bytes that it's supposed to, and the more abstractions that we have in the way of that, like the more we're assuming about the problem. But how can we assume about the future of hardware? Otherwise, like the future of hardware looks just like yesterday instead of like, something that can be actually, you know,
well, I
different.
think there's a broad spectrum of things to think about here for languages. And I think many of us are in a domain where a language is used to solve a problem. The problem's not necessarily the fastest possible way to fiddle with the bare underlying hardware, but maybe the problem is to go do something in the real world, go schedule delivery trucks,
I
go
mean,
balance the
man, this
usage of
is.
gas and pipelines versus dollars and the weather and whatever. There's
I
lots of
mean,
things going
I
on in the
don't know.
universe. And the bottom step, the last step to the hardware, it's important that somebody care about it. It's not important that everybody care about
No. Yeah, sure. I don't like. I, I'm not trying to sell this to everybody per se or whatever. I don't care about that. I'm just sharing like, um, this is actually possible. Like this whole ID that I demoed is 45 kilobytes, like in binary, and there's some scaffolding in C, and but I think I could get it fit in like 128 kilobytes. So I'm thinking that this could be a language where you could embed into the program itself to like update the program within. And I mean, it's like very simple, very fundamental. I mean, how many lines of code does it take to generate like some useful shaders where you can compile is like about 200, 300 lines, it's not that much, even if it's like, it seems unreadable.
Right.
It's so simple that it's like,
Right. All right. We're gonna walk away for a minute here because there are other problems than make shaders. There's something there. I can see it, and I can see you're excited about it. But I think I've gotten what I couldn't get out of it at this go
how
round.
would you make shaders in Java? Like, how many lines of code would that take?
Well,
That's my
that's what I'm
challenge
saying.
to
I've
you,
got other problems I'm solving than make shaders.
Yeah, I mean, like how
I'm
would you run Java on a GPU, for instance? Like it's not really possible without like, like how does Java run on a hardware that's like 50 years away? That's like, super exotic. Like,
well, that comes when we get there.
yeah.
Same way it ran on every platform that was around 20 years ago.
What I'm
People who
saying
cared
is
about the
it's
lowest level did something, but they typically started from C and assembly as a blend of those two.
yeah, well, what I'm saying is it's impossible to predict the future. So, but it's possible to make a language that's so simple that it can adapt to the future because like you can extend it, and it's so simple that like it
Uh,
fits in one
I'll say
person's
that
head.
many people want that to be true of their language, and a lot of folks strive for that as a goal. But what people consider simple and adaptable, it varies from person to person. All right. Anything else? I'm going to change topics, but I'm going to also call quits here if we don't have another topic.
To come back to the first topic and connect this with the compilers, so this billion rows challenge, how would you design your language AA so you could actually write the simple version that takes 4 minutes and have it produce the version you wrote and runs faster?
Right. So the main issue there is I recognize that the problem didn't need to allocate in the hard inner loops and that the data was very large in one direction. So I went down the path of how do I go through the problem without allocating, and I manually did all the work there to make that go. That's not a thing I suspect the compiler would do well. Now, I want to do a parallel M map and iterate over data sets could be done with library calls. It has nothing to do with AA or Java per se. The library functions for Java to do mmap are not geared toward take one giant file, stripe it across all your cores, and have every core touch a different section, except for a tiny little edge piece where they have to do edge alignment games for the end of line thing. That was a problem I did in H2O, where I eventually came up with a coding style that you started with that because the runtime covered it for you, and then you ended up with you wrote a for loop over an arbitrary amount of data. You didn't know how much. It's for I equals 1 to n. And then you did a thing per row, including plus or minus adjacent rows. And H2O would clean it up behind your back and parallelize that and make it go fast. But to have the language decide that due to the way of the description, somehow you have one giant file, you're going to stripe it. I think that's not a language issue. I think that's a library. I want to write a library that says this is a big data, walk this giant file and do something.
Maybe we still need to get closer in languages to what we have in databases, because there are query optimizers that can analyze your data access patterns and even select different join algorithms for tables, for example, depending on that. So it seems that may be
Right.
some
So
common area.
So in the funny realm of Cliff doing H2O on TCP/H queries, the old school database high performance number queries, I jammed them in H2O style and came back with answers that were as good as the best of the best brand new, most expensive database queries. Now, I wasn't a database. I didn't store any of the data. I was just doing the queries. But the actual way the queries came around were, turned into things that H2O could do directly. So there is a language for accessing large piles of data that it can be mapped to something super efficient somewhere in the universe. Now, I said that I hand did those query optimizations. Would it make sense to be a query optimizer? Maybe. The problem that I ended up with weren't things that I would say they weren't um, they weren't joins. The user wrote a join. The join had no meaning to me, or not no meaning. It had a very weak meaning to me. Like I didn't have an intuitive feel on joins. After I beat my head around what the hell they were trying to accomplish, I could then restructure the problem such that you could see where the join had been merged or melted into a hash table of bit vectors or a bit of hashes or whatever the fuck. There was all kinds of stupid other data structures that somehow had more meaning to me, and then would run parallel and scale out and be super fast and efficient. I don't know. Joins are just like not the way, in my head at least, to go deal with these big data problems. Like the first thing I did in H2O, we put a join in H2O. The first thing you do is you would tell people, strip your join out. And they would be like, what?
What I'm thinking is more general. I mean, join is one example, but to have a IR in the compiler that can express collections and can optimize collections.
Oh, that's a different one. Yeah, that's the one that says that IR has yes. I think that's a good one. Up level the core IR to understand collection semantics.
It's actually, sorry.
Well, I'm rattling on. I'm like H2O, C2 and the sea of nodes got to where the core IR understood loops sort of simultaneously as a sea of nodes and as a looping structure, as a nested series of loops, so counted loops with interesting bounds. But he didn't go any further to a collection notion. So sorry, go ahead, Adrian.
No, I was just saying like this kind of like friction between databases and I don't know, collections, low-level collections in languages. I noticed it just this week. I'm currently refactoring some code at work, and well, we have several basically we have persistent data structures and in-memory data structures. And it turns out that originally, like we need to store some messages. It's big distributed system stuff, and yeah, we need to store messages. And then later we realized, actually we want to query something by ID, so we turn it into a B-tree map or a hash map or something. And then we realize, wait a second, we actually don't want to do range queries or something. And then we keep tacking on like indirections. And then I realized that actually I'm building indices, just like a relational model. But doing it in the language is super awkward because I need to re-implement lots of logic. Now, the thing is, the thing is I get lots of type safety, and if I kind of, I don't know, instead were to like outsource it to a data, like in-memory database using SQL, like it feels it feels annoying. And also there's some overhead to it. Like I would like it to be just a function call that can get that the compiler actually understands and is able to optimize just like a query. So actually having the compiler think about like compositions of collections and actually optimize them. I mean, I don't know like what the state of the art is, but I think it's super useful whenever you have to implement like a bunch of these hash map like nested things constantly.
H2O went a slightly different direction, and there's a lot of mileage there, and it does not solve all these problems, but there's an interesting class of them that are non-obvious. H2O said compression, excuse me, and I'm going to undo all your joins and denormalize you, and you'll have repetitive uses of the same value over and over and over again where I've denormalized you. And that seems very inefficient. but repeated data compresses super well. So then we would just join everything into one big ASCII, add columns that had huge counts of repeated data, and they compress down to nothing. And they iterate for no time because iterated over compressed data is instantly quick because you don't have to, you can just skip all the compressed pieces, to the next interesting change. All the math queries on compressed data took advantage of the compression. So, all the min, max, mean, median, mode, blah, blah, blah crap, that all just falls out of the compressed data for free. And then when you went to do other things where you had to do some giant ass query and you had to join against all these things, the joins were already done. You just asked for the column of this value. And of course, it was redundantly redundant, but no one cared because it compressed to nothing. And then you just kept the compressed version. It was not much more than having the database of the denormalized thing lying around. But the access looked like you had every column. You kept every possible column that you were ever interested in instead of tucking them away into a layer of indirection, into a hash table or a join or whatever. So there's this thing that said, nah, quit doing the hash of this into that. I just do the lookup once. I'll just run it in parallel with everything else. I have one giant row. It has all your columns. There's a lot of redundancy. No one cares because it compresses to nothing. So as a way to go think about your problems, ponder that one. The iterators that H2O would use to walk the rows would do smart things with the compressed columns for the same story, or the access patterns were all cheap. So, all right, done.
By the way, this is also interesting. Like if you have a really powerful compile time function evaluation, you can inspect types and you can then build actually. Like, I'm sure there is a way to offer an API that lets you build a database for a given type with given indices with and with given I don't know, algorithms, or like I don't know, like I want this to be a binary tree, or and this index using hash map or something, and then yeah, like I think I think with Zig you can actually build some interesting really sophisticated data structures that are like super specific to the type. So
okay, I went the other way. I said everything's a 2D table.
Right.
Yeah, and then optimize the hell out of the 2D table. Yeah.
I mean, it's sort of like an indirection at compile time, what you're looking for, maybe. Like, say, like if you want something to be a binary tree or like a hash map, you said, or whatever, like they could support like a shared set of interface, and then
Yeah,
you can
the Java
get your
collection.
stuff done with like an indirection of words in the case of Fort, as I don't know how you do it like other languages that much anymore.
No, but there is a thing that says I can swap data structures if they have the same API. They typically don't. They have either cost model differences or things that one does that the other does not. But you're like adding things as you went, and then you kept having to change your data structure as you discovered new things that were exciting. Yeah.
Yeah.
That was
Yeah.
no, I was talking to Adrian's example. That was sort of the power of the H2O model, if you will, was that because it was just the one thing, it wasn't that you changed data structures, you just kept adding data, but that was all easy enough to do. And then your algorithms, which would walk over to queries, if you will, whatever they're going to do, they're machine learning a lot of it, but queries had access to everything in the simple, straight up, it's just another column.
Did H2O have some like overheads? Did these queries need to be compiled, or was it all runtime? Or
It was all
I don't know much.
done at runtimes. So the model was you wrote a query that said, I'm writing as if I'm writing sequential code, and I'm going to ask something about every row, and then I can record a row or record sums of rows or do something special with any particular row or column or whatever the hell I'm going to do. But you end up writing code that was straight line Java code that acted as if it was for looped across all rows. So you wrote a for loop that says for I equals 0 to n, and you were passed in as a function all the column entries. Now do something. And because it was a for loop, you could go plus or minus, and you could go plus or minus a fair amount. That was fine if you want to do nearby guys. But if you were like, I want to go do a little logistic regression to decide what are the percentage odds that I should loan you money, and I have some columns and some zip codes, and I have names and salaries, and I have prior history of loans and whatever, blah, 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 and you kept joining data and you kept adding more and more columns, then when you run the core inner loop, you probably did something that looked like for I equals 1 n, I have all these columns do something. And in case of logistic regression, you're going to multiply every row by its weighting factor and add them all up and then run them through the inversion function, blah, 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 whatever logistic regression does. But you could do a query. It says, hey, find me everybody who has the following salary range. Find me everybody who has the following salary range plus or minus this. And we would just run across the whole data set and run this query on every row, except it would be running at memory bandwidth speeds. So a terabyte of data would be done in some number of seconds, and gigabytes of data would be done in fractions of a second. And it would fit, many gigabytes would fit on a laptop and be done in a fraction of a second. It was all easy and quick. And you hack a line of Java code and you hit to go, and it would spin and just do it. So it was easy enough model for less robust programmers, so mathematicians and data scientists who program, but they're not systems engineers. They're not writing distributed scale-out computing things. They have math skills that are different. Yeah, you grinned at me, but I was serious. They could write Java code, plain old stupid Java code, and get good answers out really easily. Hack the data, run it again, hack the data, run it again. They had no trouble with that piece of it.
Yeah, the art of computing, my friends. It's like it's not. I think we've actually gone into a parallel universe where if Fort ideals could have imagined differently, then we wouldn't have any of this. Because I think trying to compile from a high level language to a low level representation, because you want low level representation because you want control at the end of the day, but to express that control programmatically at compile time, I mean, that's what we actually want. And if you include anything that's runtime specific, then that's just a very limited mindset that's trying to solve a problem that it doesn't even know about, because the problem can be imagined, the optimizations are reimagining the problem space in a different way.
You're rambling, and I'm trying to draw a conclusion out, but I'm missing.
The conclusion is all of our solutions are just solutions trying to find a problem to solve, a problem to map to, versus we need to understand the problem and map it to a language that's as small as possible to express our exact intent, versus
I'll tell you what, why don't
trying
you
to anticipate the intent, right?
Right. The issue here, of course, is that what people want to solve is not shaders. There are many problems people want to solve, and that's just one of them.
Onat, I wanted you to come up with a good abstractions for
it's hard for us
doing
to come
what
up
you
with good
do.
abstraction. Yeah, that's a fair answer.
Okay. So
we're going to wind it down.
Describing is
Okay, wait.
What was that, Nara? Yeah.
All right.
You'd be amazed the things people squish into the shape of a shader.
Okay, fine. Maybe I should go study up on shaders.
Okay, honestly, since we're starting shaders, let's wind up again. All right, so I've recently written a few good shaders, and you can do some really cool stuff. So yeah, two things very quickly. One, shader for I was working on making there's an arrow that in my game there's an arrow that you can, I don't know, put on a bow, and then you stretch it, and then the bow stretches a bit, and then you shoot, and then the thread wiggles a bit. So yeah, I did that in a shader and felt super satisfying. And currently I'm working on a lightning shader, so you get a nice, cool lightning impact. Yeah, that's it. I love shaders. They look super nice. They make great blog posts. Very good marketing material.
Well, clearly, next go round, you should lead in with what a shader is and what you can do with it.
I'd actually like. I could maybe get shaders done until next week. I've been like super burnt out for the past 2-3 weeks, so I didn't get that much done. But like the thing is, it's about understanding the GPU hardware architecture. Like if you want to understand shaders, you have to start at the hardware, and the hardware is like
all right, we're not going to go down the line of what a hardware GPU is right now because we're at the limit here.
Okay, I'll just leave it at the best shader I ever saw, which was that Chrome had just launched like that day their WebGL thing to allow you to use OpenGL commands directly on the web. And someone made this demo shader that you would go to this website and it showed you this long loading scroll bar, and then your screen would flicker, and you are now running from a restored Hibernate of an Ubuntu run because they had used the shader, which could talk to the DMA to overwrite the entire kernel memory and then jump into the beginning of the kernel memory. So even on a Windows box running Chrome, by going to this website, you are suddenly in a live CD of Ubuntu, having restored from a Hibernate image.
Wait, it like crushed like the OS, like Chrome let you got past security in the OS kernel and let you crush the
Right. So the kernel only lets the DMAs talk to certain parts of the memory because some of the memory is owned by the kernel.
Yes.
The GPU was a DMA that didn't follow those rules because, at least at the time, most GPUs didn't have any kind of hardware protection concept of what was kernel memory or what was user memory. So you could overwrite any memory when the shader was putting data back to the GPU.
It sounds like a
And it turns out that they had to go through in Chrome and just straight up blacklist, disallow a whole bunch of GPUs because if your GPU didn't actually implement the kernel memory protection part of the DMA spec correctly,
right,
the shader would just allow you to arbitrarily overwrite memory and then jump the CPU. But it was the best shader I ever saw was the on Windows, go to this website and you're now trying out Ubuntu.
All right, done.
That's
Done.
possible. I mean, the thing is, like, GPUs are
done. Sorry. Next week.
No, no, you cannot like suppress like the GPUs.